Test. Uh, this is where we stopped last Friday before the Chinese New Year. Okay, maybe first answer a few questions. Can all hear and see the slide? Maybe maximize the slide first. Full screen. This is where we stopped last Friday makeup lecture. The video is already on in the channel. So yeah, I hope all have watched the where we stopped last Friday. This one. So we have covered, okay, so last Friday lecture to cover this Tuesday lecture, we have covered the idea about the stack and cube. In short, actually, stack is the last in first out data structure. I would say it's a concept. Yeah, so actually I can implement the stack in linked list or array. It's not the new data structure like what you have learned the linked list. It's just a concept that the structure, the data is stored in this manner. The data is only can be last in first out, only can be first in last out. In short, you always only can access the element from the top. You only can access one element in this data structure. Yeah, so you only can add and remove the data from the top. That is the stack data structure. Queue is the other, is like what you are doing every day queuing. So it's first in, first out. So the first data enter this data structure will be the first data removed or access. You can access, yeah, the first in, first out. That is the concept of the first in, first out. That is a queue. So in other words, you enqueue your data at the tail, and then you remove your data from the head at the front. So again, you also can be implement by array, but normally because you need to insert and remove the data, so probably the linked list is a better option. Same thing as the stack data structure. You also can implement in an array, but linked list is the better option. So we have covered their implementation to you. So in short, stack you only can pick, push, and pop. So everything you only can work with the first element at the top. Yeah, you can inspect, you can add the data, you can push it in, you can pop it up. Everything is at the top. So that's a stack. There's their implementation. So then the queue also similar. You'll get front because basically we are not interested about what it is at the tail, which you just enqueue it. So normally we only get front at the front. You only can get the item at the front by get front function. And queue, that's when you're trying to enter the queue at the back, add the item at the end. Then dequeue is remove the item from the top at the front. Yeah, that is queue. 3 typical queue function you need to use. And I already released the lab and the assignment. You should receive the assignment. And yeah, I also include the assignment MCQ. So of course, the MCQ part won't have any plagiarism check. That is only contribute a very small portion. That's mean if I think the programming question, you have 3 programming questions in assignment 2. Each question is 100 marks. That's mean you have 300 marks in total. Plus the MCQ, we have 4 MCQ questions. Each question is 5 marks. So it's 320 marks. So MCQ only contribute out of 20. Yeah, out 320. Yeah, 20 out of 320 marks. Is very small, just for you to understand the concept about analysis of algorithm in the MCQ. So yeah, and yeah, it's inside the when you yeah, when you do the assignment, you will find there are another 4 questions there for you to answer, just an MCQ question. So to let you familiar the interface also. So that is the purpose I put a few questions over there. During the final quiz, yeah, you will have a similar format. Instead of 4. There are 3 plus, no, more than 1 MCQ. You have 4 MCQ. The assignment one, there's no MCQ. Yeah, it's from assignment 2. I just find, yeah, maybe just put another 4 MCQ question there for you to try it out. To familiar the interface also, during the test, you will encounter something in, yeah, similar format. In the lab test one, there's no MCQ. Lab test one is purely the programming test. We only do 20% MCQ final quiz at week 14 together with the lab test 2. So in lab test, so I named it is like final quiz and lab test 2. So actually there are two tests conduct at the same time together. Or you can think it's like same test, just have this test got 2 sections. One section is an MCQ, another section is a programming test in the final test. Yeah. So that is the things. And also I noticed quite a few students like to use all these functions. It's okay. If I provide you this function, you can use it. If you want to declare your own function in the assignment, also fine, you can use it. That's not an issue. But when you use so many this function and QDQ, yeah, you need to think about it during the test. I may not provide all these things to you. Yeah, and it's a closed book test. Then you want to go and memorize all these functions, or you go and really solve the problem directly. Yeah, sometimes I think there are two all this data structure. You find that there are 2 levels. One level is, yeah, learn how to implement this kind of a function. That's when you play around with the linked list to insert a nodes in arbitrary location, do the swap the nodes. That is one thing you need to learn. Another thing you need to learn is reuse those given function. That's when insert nodes, remove nodes, or push port and cube decube. If I give you all these functions, will you be able to reuse this function to solve the problem? So there are 2 types of questions you need to take notes. If it's a latter one, that means I will provide you this function for you to reuse it. So to solve the problem, you are trying to call those functions to help you to solve the problem. But sometimes it may be like the assignment one is I really want you to play around the swapping the nodes in the linked list. Yeah, probably it's not very good idea to use the insert nodes and remove nodes. Although you also can solve the problem, but you need to add such a big insert nodes and remove nodes function to solve it. Yeah, maybe not a smart way. Yeah, so just take notes. For assignment, I don't mind. You can up. Yeah, I let you to choose what is the approach you need to do. It's just like you need to think about it. If today you use this kind of approach to solve this problem, then how are you going to solve the problem during the lab test when we're not providing you all these functions? Yeah, you probably average I aim is like in the lab test you should be able to solve each question probably will take half an hour. So within half an hour, you not only need to re-implement all these utility function, you also need to solve the problem. You may run out of time. So it is better to use only the function given. Yes. Plus, sometimes you may need to, you want to modularize certain portion. You can declare your own small function to help you. Because you find that certain small function, you need to repeatedly call it again and again and again. Yeah, maybe that is a good idea that put a small function on top of it. Then you can simplify your implementation to accelerate your implementation. that maybe is a good idea to do so. That is okay. But you pump in so many functions before you start your problem. You need to think about it. If during the test you don't have those functions, are you able to solve the problem or not? Yeah, that is the problem. You need to think about it. So back to where we stopped last Friday. This stack and cube. And today I'm going to discuss one of the problem which can be applied the stack, which is the algebra expression conversion. That means I will introduce you the infix expression, prefix expression, and postfix expression. Okay, yeah. To clarify one, assignment, I purposely set it harder, but doesn't mean the lab test will be same as. Again, the same question won't reappear in the lab test. Lab test question will not be exactly same as the assignment. Assignment is for you to practice your coding skill. So have to, yeah, since it's a take home, you have so much time to do, then will be harder than the lab test. Yeah, so don't misinterpret that the question will be same as the assignment. So, okay, back to this. Yeah, don't discuss about this assignment further. Otherwise, I'll run out of time. So this today I will discuss about this algebra expression conversion. Is how, yeah, the stack idea is simple, but in how are we going to use it in practice? A few example in the lab 2, you will see how to use the stack to do the balanced paradox problem. Another example, you will find that in practice a lot of, if you want to convert any recursive function into iterative function, actually we are using the stack. Because when you do the recursive function, you will find that every time you do the recursive call, actually computer internal there's a stack memory. When you do a recursive call, every call will push the status of this function call temporarily into a stack memory. And when you reach the base case and you start return back, they will pop up the last in first out. So the last recursive call will be pop up and return back and return back and return back. Eventually you back to the main function. So normally that is how the recursive function work. So if you want, generally speaking, all the recursive function is possible to convert it to iterative version. That means if you want to do that, you probably need to declare, especially those hard recursive function, you probably need to have a stack memory, a stack data structure to help you to store some information in each recursive call. So in other words, recursive function is implicitly there's a stack data structure done by the computer. And you need to convert it to iterative version. You need to explicitly declare a new stack data structure to store those information in the stack. So that is one of the typical application example we use the stack data structure. For Q-wise, the typical example, palindrome, I think just now someone mentioned, I would say yes and no lah. I think you can probably also use the stack. I also can solve the palindrome problem. Yeah. The better example probably is the scheduling problem in multitasking, in network, in your router switch. All these have some scheduling to schedule when you have a lot of package you need to send from different user, or you have multiple tasking problem. All this kind of function or application, they internally normally have a queue to store the task, to queue up the task, to queue up the package, to queue up the message you want to send out. So that one end, they were trying to let all different tasks or different user to send their message to enter end queue, and the other end will process the queue, the message in the queue, the task in the queue. Yeah, so will be first in, first out. Those the first one enter the queue will be the first one dequeue it and process it. So that is the typical queue data structure we use in daily life. Yeah. Yes, so in the lab, lab 2 question 1, I did give you the paradron. Yeah, probably I find that actually I use the stack to solve that problem also. Yeah, so you can use a stack and a cube, or 2 stack, or 1 stack 1 cube, you can solve that problem. So these are the things you can practice during the next week lab section. I would say the lab question or assignment, the objective is not trying to look for what is the solution. In fact, my solution may not be the only solution or the best solution. You always can think out your own solution, and you're supposed to learn how to find out your own solution rather than you go and look at the solution, the given solution, and memorize it. Then you will find that during the test, you still don't know how to solve the problem, because you never go and learn how to solve the problem. You only know what is the solution. You don't know how to get the solution. The objective is in this lab, all the lab objective I trying to design it is like you need to try to find how to approach and find your own solution. And when you encounter the problem, you make a mistake, how you find how you debug it, how you fix your mistake. If you simply look at the solution, you will find that you just simply understand that is the answer, okay, but you still don't know how we come out the solution, how you can think, how you analyze the problem. Yeah, so this module you should learn is improving your analytical skill, your analysis, how you analyze the problem, and to how you come out systematically, come out the procedure and solve the problem. That is so-called the algorithm. And then the next step is how you improve your programming skill to realize the code. So in the next part, you'll find that I'm not going to show you the code I want you to from the pseudo code to how to solve the problem. Algebra expression conversion is just a problem. Yeah. And if I give you another problem, how you approach it is what you need to learn. So in this particular problem, actually I'm going to use a strategy is we name it is like a transform and conquer. When you find that this particular data or representation is very difficult to solve the problem, sometimes we will transform it to another form, and then before we solve the problem, that means we do some pre-processing. We change the representation, and then you will find that the problem becomes easier to solve. That's so-called transform and conquer. We're trying to change it into another format to solve it. That is very common in engineering. So for those who have learned about the signal processing, instead of use the signal directly, sometimes they will use the Fourier transform to transform the signal to in another format. Then you will find out the frequency the frequency of the signal after you done the Fourier transform. Then you can see some hidden information. So this sort of a transform and conquer can help you to solve a lot of daily life problem easily. If you want to directly use the raw data to solve the problem, sometimes may not be, you will take more times or harder, or you may not even able to solve the problem because the actual information is hide behind, which you cannot easily retrieve out without any transformation. So that is one of the common in engineering. It's very common approach we use in engineering. Transform and conquer. So I think you probably know how to solve this kind of algebra expression. You have learned it in secondary school or primary school. A plus B times C minus D times E divided by F. So this is typical, we call it is an infix expression. Infix expression, that means your operator you put between two operand. So you want to A plus B, you will put the plus in between A and B. So that is called infix expression. The operator is put in the middle. So typically we do this kind algebra expression. There are two rules. You need to know the presenter's rule. That means that you will do the multiplication first. So in this particular expression example, I expect you will do this one first, because multiplication you will do first. Then plus and minus, addition and subtraction, you will do it later. Then there's another rule is the left to right association. So you will do from the left to the right. So very naturally, so always for me, I look at the problem, I wouldn't rush to implement or solve the problem. It's how I myself do this particular question. I will do this one first. Next, I probably will do this one. Because left to right, I will do the d times e first, followed by divide by f. Then after that, I will do this. Then subtraction will be the last step I need to do. But you will find that if I do this, why I know b times c need to do first? Why when I see this expression, the first thing I look at it, you will find that actually every time, without any, of course you can provide some paradox to guide the person, but usually we don't need. We look at it, we after so many year practice, you already very naturally you will see this particular one will be the first step you need to do. But probably you have never go and think about why you can instantly see b times c is the first one. Yeah, actually what we did, probably I don't know, maybe for me is probably I scan a few times and then find out where is the first one, which one have the higher percentages, and which is the leftmost operation I need to do. That's why I find out there's b times c. So if I really use this algorithm on this infix expression, I need to keep scanning the same expression multiple times to find out the first operation I need to do, then the next operation I need to do, the next operation. Every time I need to keep scan to sort out the order. That will be very obviously the time complexity will be beyond linear. So, but you find that our calculator, when you place, they're very fast to decide, which one should do first, which one. How actually our calculator work on this given for scientific calculator. Those scientific calculator, they will help you to sort out the order. Yeah, but how they actually work, or when you write in your programming, when you compile the program, you give an expression. The compiler also know the order, and they also do all this evaluation from left to right association. They even further have more than that, multiplication, division, modulus. In C got modulus. There are another shift. There's a shift right, shift left, a lot of other operation. But they're very smart that they know you give a long expression, they can find out which one to, when they compile, how they know the order. Yeah. So it's so-called the infix expression is what we normally use for algebra expression in our daily life. But computer, you will find that to let computer work on the infix expression is very difficult. But how actually the compiler, you give the compiler the infix expression, how the compiler know the order? Because inside the compiler they do something. Actually they do some transformation. Yeah. So yeah, how the you type in this expression in your compiler, how the compiler know that this is the first expression. Yeah. And from this example is another one. You probably, how you know this particular one? For you, for for so many years practice, I think you should not have problem from this is the first one. The next one, because left to right, this one, all these have the same order. So I probably will do this one first, and then next one will be do this one, then the last one will be do this one. Yeah, but how actually I can solve, how to have a more systematic way to sort out the order. You will find that when you use your calculator, you type a number, then you type plus, a bit slow, plus, then after that you type b. Then they don't do, when you do the multiplication, they don't do a plus b, because you put a multiplication. You notice that when you when you use your calculator, you type some number, then you plus it, then after that you type another number, then you type the multiplication. Actually they don't do the a plus b because you type in the multiplication. But when you type c, when we type the minus, do you find that the calculator will do the b times c? So implied that actually the calculator know that they can do the execution. They can execute this particular operation is because when they see this minus. When you see this minus, you will find that you can do the multiplication. Actually, what the calculator did, they do a transformation. They already transform it, to another form. This one later, the next slide, I will explain. So if I can transform this expression into a postfix expression, you will find that the thing will be easier to solve, much easier to solve. How this, if I can transform, let's say I can transform. Later I will explain how I transform it. First we see after I successfully transform into postfix expression, the problem how easy it can be solved by using a stack. If I have this format, remove this animation. Okay, if I have this particular format, I just need to have a stack data structure. Every time you read from one character by one character, from left to right, A, then you just push it. Whenever it is an operand, is a number, is whatever, as long as it's not the operator, I will just push it, everything, I just simply push it into the stack. Because it is a postfix. Postfix means that you put the operator at the back. So whenever I encounter an operator, that means multiplication implied that I can execute this operator with two operand. So I just need to pop up two operand. Then I can do the multiplication. Then I got a new value. Then this value will push it back to my stack. And then I can move on. The next one, I will encounter the plus. Then I will pop up 2 to do the summation. That is what I'm trying to do here. So this is the postfix expression. In other words, this particular postfix expression, somehow they already sort out the order. You will find that the first one you will do is multiplication. The second one, the second operation you will do is the summation. And then multiplication, division. The last one will be here. The last operation, which is a subtraction, will be put in the last. It will be always a last character in this expression. So how actually we come out this expression? Okay, once we have this expression, the evaluation will be very easy. I just need the stack. The stack store all the operand. Whenever I encounter an operator, I just pop up 2 operand and then execute it. The result is a new operand. I just push it back. And then every time I just repeatedly do this until the end of this expression, I will find out the answer. So the whole operation, you will find that it will become linear. You just need to read from left to right. Then all the operand will be pushing into the stack once and pop up once. You won't repeatedly push in the same operand again and again. Every time you push it in, evaluate, you push it, the result will push it in. So overall, it should be a linear. You expect that the evaluation will become a linear. You only read it once, from left to right. So now the next problem is how to convert this particular expression. You will find that if you read your infix expression, why you know you need to do b times c and a plus b times c first is because you see this particular one. It's because of this. When you see there's a minus, you will actually, you know that this is minus, implied that whatever before that, this one have higher precedence. Multiplication you need to do first. So definitely when there's a minus here, implied that you can do this one, no problem. After you done this, definitely no problem. You can do this particular summation because there's a minus here. So definitely you can do all the operation before him, which is lower precedence or equal precedence. Because left to right ma. So plus definitely do first. Before this minus. I don't need to care what it is behind. So the conversion definitely will do this particular process to sort out the order. So they can sort out that multiplication will be the first one. Second one will be summation. The third operation is multiplication. The fourth one is division. The last operation you need to do is this minus. So how actually they do the conversion? Yeah, that is the problem we want to discuss in the next half an hour. This expression, first you need to just introduce you that this is a so-called the postfix expression. In this particular expression, we put the operator at the back. Infix is put in between. Postfix is put at the back. Yeah. So the operand will put before that. So that is a representation. And how do we convert? The key I want to discuss is how do we convert from infix to postfix? Yeah, like I said, you will find that all these things you will just, if you base on how human being do on this in fact, this particular expression is come before we have computer. If you go and check, it's more than 100 years ago. Some Polish mathematician come out this particular notation. So actually we do this is like B times C is BC multiplication, DE multiplication. Then after that, we based on this order, we will do this one first. So it's ABC times plus, then DE multiplication, then F division. So for the good thing for postfix, they don't really need any paradox. They don't have to put the paradox. You can see that actually they are already in order. This one will do, and then followed by this one. After that, you will do this one first, then this one, then the last one will be the minus subtraction. Yeah, how actually systematically come out an algorithm to do this conversion is what we need to learn. Yeah, so this is the pseudocode. How actually this pseudocode work? So basically, if you have a expression, so let's say this is a string. We're just trying to read from the first element to the last element. Here I further include the paradox. In infix expression, we always use some paradox here and there, or blanket or whatever you additionally. Of course, I can add more. Yeah, you just get the idea. You can further extend this algorithm to solve more complicated expression. So, but the idea is like they're trying to read from the left to the right with a stack to help you to sort out. The objective to come out this stack is trying to help you to do the sorting, to sort out the operation order. So whenever you read is an operand, this portion. Whenever you read is an operand, you just put it directly to the output first. Whenever you encounter a operator, at this moment, let's say you don't look at the following expression. When you read the plus, actually at this point, I won't be able to know whether of course I don't have enough things to do any operation. I will temporarily push it into the stack memory. That is what this particular part are trying to do. Whenever they encounter is an operator, they were trying to push it into the stack memory. Then whenever I encounter is operand, I will just put directly into my output. when I encounter the multiplication, before I push it in into the stack memory, I do some check. I will check whether inside my stack memory, this is, now it's a plus inside. I check whether plus and multiplication, which one have higher order. So what this particular part trying to do, because multiplication have higher order, in other words, you will do this particular multiplication first before you do the plus, right? When you read this one, actually before that there's a plus, there's a addition. You definitely do the multiplication first. Imply that this should be the first this may not be the first one. This definitely will do before the plus. So in that case, because the presenters interpret into programming language, as in it's like the multiplication have a higher order, is greater than the presenters of multiplication is higher than plus. In this case, I would not pop out anything from the stack. I still simply push it into the stack. Yeah. But I also won't be able to know, at this point, I still won't be able to know that I can do the multiplication first. Yeah, I need to read a few more characters, then I can judge. So the next one, I will read the C. C, it's just an operand. I will just display. So it's called ABC. Then the key is the next step. At the next step, I read the minus. There's a subtraction. When I read the subtraction, at this point, that is the key. I know that I can do the multiplication is because when I see there's a minus here, there's a subtraction. When I read there's a subtraction. Subtraction have, the presenters of subtraction is lower than the multiplication. When you see there's a multiplication here, this is a subtraction. Implied that, definitely I can do the multiplication first before this subtraction. You don't need to bother what is this behind. Whether what is the expression behind. Definitely at this point, you're already pretty sure that B times C you can do first. That's why they pop up the expression. This expression can execute. Not only this, plus addition definitely can do, because left to right association, you definitely can do the plus before the subtraction. Subtraction at this point, I don't know whether I can execute it or not. So this one, I don't know whether I can execute it. So I will push it in. So that is this algorithm, the idea behind. He's trying to use a stack to sort out the order. So next step. Again, you will find that just now someone asking whether can use the cube. Probably not. You will notice that the stack memory is help you to do the last in, first out. The multiplication is the last one enter. So you will be the first one remove. Because whenever you find that you can execute, you will quickly pop up and put into the output in the postfix expression. And those you cannot determine, you will push it into the stack and wait for further information. When you read D, okay, you just simply put into the the prefix. When you read the multiplication, multiplication is higher than the subtraction, so you still push it in. At this point, I won't be able to know whether I can execute the subtraction or not. Then multiplication, of course, I also not too sure whether I can do it or not. The next step, when I see there's any open parentheses, I will just simply push it in. So this parenthesis is made like a section. In short, this is a separate expression. I need to convert it to separately. So I put a break line here to indicate, at this point, you don't need to care. We break our stack separate. And then we carry on E. We still put it here. because this part definitely will do first. Division, yeah, because there's something equal to this open parenthesis. So this division will push it in also. I don't need to check the rest. Again, stack only check one element at the top only. So it's good enough. So the division will push it in. Then when I read the F, when I read there's a closed parenthesis, I will this part, yeah. I will pop up everything because this is the end of this sub expression. E divided by F is N. You can have a very wrong expression inside. So when I reach the end of this closed parenthesis, I will pop up everything until I encounter this open parenthesis. I will pop up everything, all the expression, division, all pop up. And then this one will throw it away. Don't need already. So EF division. EF division operator. Yeah, this one will be here. This is the sub postfix expression for this portion. Then after that, well, in this particular example, I already reached N. Anything still inside the stack memory, I will pop up. So definitely the next one you will do will be the D times E. The last operation will be here. This will be the last one. So that is how they convert from infix to postfix. You will find that in this algorithm, the sorting key is this particular things. They sort out. This one is the first rule. The presenters, you need to do the multiplication and division first. And addition and subtraction, you do it later. So this rule is decided by this particular part. And you use the stack to help you to sort out the order. And the left to right, yeah, the left to right association is decided by, actually, if you think about it carefully, actually it's decided by this particular one. The equal. Yeah. Why is greater equal? It's because the left to right. So I think in the assignment and the practice question, I asked you about another representation. Instead of postfix, of course, there's another representation called prefix. Prefix expression. Prefix expression is put the operator at the front, at the beginning. That's when if you have the E divided by F, the prefix is divide E F. This is a prefix expression. This is a prefix expression. Actually, you will find that actually they are almost, I would say almost exactly same as the prefix expression algorithm. You can go and try to right now how to convert the infix expression to prefix expression by your own. You'll find that the whole procedure are almost exactly the same. Yeah, but just something you need to take notes that there's a left to right and right to left association. When you do the conversion, you can reuse this algorithm. You just need to take notes that when you reuse this algorithm, yeah, you need to take notes these particular things. Yeah, actually I already of course all this I not suggest you to go and search online. Definitely this algorithm have been more than 100 years. Nowadays it's quite easy to find out the code online. But the interesting is like online, yeah, there are a lot of code are not correct. Especially for the prefix expression, they miss out something. Actually, it's one person miss out. I suspect it's one person miss out something. After that, subsequently, everyone just follow that particular wrong expression. And why I said it is wrong is not because simply I said wrong, then it's wrong. The reason I find that it's not correct is because I cannot if I use that particular code, I wouldn't be the prefix expression I have, I wouldn't be able to convert it back to the infix expression. This means something is wrong in the conversion. If you can do this conversion, supposed to be I can do the infix expression to the postfix expression. When I convert it back to the infix expression, I'm supposed to get the same thing. If I cannot, that means something is wrong. If you can go and play around with it, you will find what is the problem. The reason is something at here. You can think about it. Why they miss out this thing. You won't be able to get the correct answer. So back to, if the blanket is E plus F, then once it's done, the postfix expression will true. Yeah. In the postfix expression and prefix expression, because they already sort out the order, the operation order. So actually they don't need any blanket, parenthesis, curly blanket, whatever. They don't need it. That's the good thing to have the postfix expression or prefix expression. You don't need all this. They can remove it. But in the infix expression, you always need to have some parenthesis to guide you which one should do first. If you want to do something before that, like this one, if I want to do E divided by F first, I have to indicate the parenthesis. But in the postfix expression or prefix expression, they always sort the order properly for you. So you don't have to, so in the postfix expression and prefix expression, normally we wouldn't use any blanket, parenthesis, whatever you name it, to guide you. Yeah, you don't need, you already sort the order already at the beginning. Okay, so once you can convert it, then just now the evaluation will become very easy. I just need to have another stack, and then in the stack will store whenever it is operand. Yeah, this time I'll push the operand into the stack. Yeah, from it. Yeah, when I read the postfix expression, when I encounter the operand, I will push it in. I'll push it in. Whenever I encounter the operator, I know that I can evaluate immediately. I just simply pop out two operand, C and B, and then do the multiplication, and then push it back. So you will find that in the original expression, this is the first one you do. Next one, you do the plus. You also pop up 2. So that it will be the second one you're going to do. Then you push it back. Then you carry on to read from D, E, F. All these are operand. Just push in. Then when you encounter the division, you will find that actually this is the next one you're going to run. You're going to execute E divided by F. Then you push it back. Yeah, you can see that the whole process, I just read from the left to right once. I don't need to keep scanning which is the next one. So you are improving the evaluation times. This one done. Next one will read the multiplication. Pop up 2. Evaluate it. Push it back. Then next step will be this one, the last one, minus, which is the last step. Then you got the answer. So the whole process, you can find that you only read from the left to right once. So this can consider the complexity is a linear. Yeah, you can see that in the algorithm here, you only run one for loop. Overall, the evaluation is linear. Another one, this one already mentioned. Yeah, prefix will be the similar. You will find that this is the corresponding prefix expression. So from the prefix expression, again, you will find the difference is like, if you compare just now that one, the last operation will be here. The prefix one, the last operation is definitely here. You find that always true. You have whatever expression, the last operation definitely is the first character for the prefix expression. in the postfix expression, the last operation definitely is in the last character. Then here, yeah, in this particular expression, the result, you will do this one first. It's also fine. Then you do this one. You will probably do this one. Then you can do this one. Then you do this one. Then the last one you will do is this one. The order a little bit different, but definitely the last operation is correct. That will be the last operation in the prefix expression. So probably normally I think we normally use the postfix expression because that order is left to right. You notice this one, yeah, there's something not very, yeah, the order may be not very correct. Although the answer, the result still okay. Yeah. So that is the difference. You find that the conversion, if you go and work it by your own, you will find that actually the algorithm should be, you can probably 90% are exactly the same. You just need to do something a little bit, yeah, and then you need to consider the presenter's part, yeah. Additionally, a little bit, you need to change a little bit, then you can get the conversion. This is what I left for you to think about it. I think I think try not to go and simply look at the online code or this directly. It's good that you go and the thing you need to learn is today this is the problem. I want to convert the infix expression to a prefix expression, and how actually you yourself going to approach this to find out the solution by your own. And you yourself first, you need to learn how to convert it. After you understand how to convert it, the next step is how to come out a systematic procedure. A systematic procedure, that's so-called the algorithm. After you come out the algorithm by your own, and every step is well defined, then you probably can, the next step is your programming skill, how to write the program, implement it to realize the algorithm into a computer program. That is what you need to learn. And not the thing no point to learn is like you go and read the code. Oh yeah, they're doing this way. First step doing this, second step doing this. Oh, I understand it. You still don't know how to. Next time, give you another question, you will find that you still don't know how to do it. Because today, if you read the code, you only learn the answer of this particular problem, the solution of this particular problem. You still don't know how to solve the problem. You didn't learn anything really useful by doing so. That's why I try not to simply release all the solution to you, because the objective for this module is not learn the solution itself. It's learn how to approach to get your solution. So my solution is not something important. It's how you yourself come up the solution by your own. It's something you need to learn in this module at this level. Okay. So to summarize this week lecture is, yeah, we introduced the stack and the cube. It's a concept. I have to emphasize it's just a concept. The stack is a last in, first out. Cube is just first in, first out. That is the idea behind the stack data structure and cube data structure. But it's not really a new data structure. I can use the linked list. I can reuse the linked list to do additional restriction on the access, on this access. Then it will become a stack data structure or cube data structure. Nothing is new. And we also introduced several variation, circular linked list, doubly linked list in the earlier last Friday cover lecture. Then in this lecture, I introduce you another algorithm strategy. In fact, algorithm design strategy not just used for implementation, you also use in your daily life. When you encounter some problem, you find that this kind of representation may be very difficult for you to solve the problem, or every time you can't come up a very systematic way to solve the problem. Probably you can think about whether you need to do some processing on the data to transform it to a proper, better representation, and then you will find that you after you do some pre-processing, the process, the evaluation, the subsequent algorithm will become easier and simple. Yeah, that is what you can see from this infix expression to postfix expression. Why they need to do this conversion is because after that the evaluation algorithm will become easier to do. You don't have keep scanning the order. They through this conversion they can help you to reorder and sort out the order properly, and you can solve the problem faster and easier. You simplify your implementation also. Later, I think when we cover the tree, we will there's another problem when we face the tree structure is imbalanced. When we do the disbalancing, that is also trying to transform the tree structure into a better balanced form. Yeah, that is also a transform and conquer. I will show you in 2 weeks later. Yeah. Okay, so that is today's lecture. Maybe can answer a few questions. The assignment 2 is already extended to next Wednesday, because soon I will release the assignment 3, probably next week after I cover the tree structure. So it's a bit hard to extend. You expect that you have the 3 hour, 36 hour. So definitely 14 days times 24 hour, you have sufficient times. So I think I still see a lot of people haven't logged into your assignment. Yeah, actually don't have to worry. You have 336 hours. As long as you don't go and click the end test, you definitely have sufficient time to do your assignments. Yeah. The assignment, I don't get all correct. You won't get 0 marks because I trying to put so many test cases. If you cannot get all correct, you won't get 0 marks. Every test case contribute certain weight. Some is 5 marks, some is 10 marks, some is 20 marks. Depend the complexity. Actually, a lot are very similar. Normally for assignment 1, you need to consider is like, if I only put one element inside, if I put the even number, if I put the odd number, do you consider all this scenario? That's some people may not do all this consideration. I don't want to show you, I don't want you to go and target particular test case and then go and modify and change your code and keep testing. It's try and error. The purpose, the right way to solve the problem is you should go and think about it. For this particular question, what are the possible scenario I need to consider? Like sometimes you got even number, odd number. Sometimes you need to consider is like only one node is in the data, or some special case. Do you consider all the possible case? That's one thing. And then another thing you need to consider is, I didn't put too much about the time complexity issue, but there's a default setting. The platform won't allow you to stay there to run your program forever or take 1 hour. I think normally 5 seconds they will simply kill your program. So you must complete your program within 5 seconds. But sometimes I will give a very, very, very long, maybe 10, also not very long. Actually, in practice, they use a few megabyte data. I only use 10,000, about 10,000 data or 1,000 data. 1,000 nodes to test your program to see whether you can complete it within the time limit or not. So some people may have the problem is like their program is very inefficient. They trying to create a new linked list. I can see some people create too many linked lists to solve a problem. But I want you to reverse it. It's supposed to be just swap the nodes order, not really ask you to move it to another new linked list, and then you create another new linked list, and then you swap it, and then you remove insert multiple times. That will not only increase your time complexity, also increase your space complexity. So can we use, but the compiler is the C compiler, probably C++ is not, yeah, you won't be able to get the compilation successfully. So yeah, will the assignment auto submit when the times is up? Eventually, when there's a times up, I will, yeah, at the deadline, I will close the assignment. That's it. At that time, they will automatically end all the tests. But if you already complete the assignment, you can simply end the test by your own. So will you give us the function during the lab test, like insert notes? Yes and no lah. It may be depend on the question. If I find that, for example, I just want you I want to test you, for example, in the assignment, I want to test you whether you know to give you two notes at two different locations, you want to swap it. Yeah. My objective is not want to test you whether you know how to use the insert notes and remove notes. I want to test you whether you really know how to swap two notes. Is the objective. Then I probably try not to provide those functions to you, because that is not the thing I want to test you. If I want to test you how, yeah, let's say I give you insert notes, remove notes, I give you push, port, like for example this infix to postfix expression. The objective is want to test you whether you know this conversion. Then of course I will provide all this utility function in this case. So it's depend on the question. Our answer to the question be submit as long as press submit code. Yes, when you submit code, actually they already show you that all the hidden test case, which one you is accepted, means that you it's okay, you already passed. If they return some runtime error, whatever, the output some error message, that means you didn't pass certain hidden test case. You have to go back and think about it. What are the cases you miss out, or where you make any whatever mistake you make in your algorithm, in your implementation. So if it does not allow more than 5 seconds, yes, it will be runtime error. Runtime error, there are I think you can expect there are two possible scenarios. One scenario is like they cannot complete the given data. The halfway they have to kill your program. Another one is like sometimes I can see some student is like they didn't do the memory allocation properly. They keep their pointer already lost. Then they will run infinite loop. That's why they have to kill the program. Otherwise, this particular program will run infinitely. Then the whole server may be crashed because of that particular program. So they want to prevent such thing happen in their server. They have to kill the program after certain default time limit. So have to take notes. You if I remember correctly, the default is 5 seconds. I didn't put, yeah, suppose actually I should reduce, because my test case is relatively simple. So actually within 5 seconds, less than 1 second, you already can finish the program. If it's go beyond 5 seconds, that means something is wrong. It is safe to say that you get full marks in the test case. It means if there's no any plagiarism, any cheating, I would say yes. If you pass all the test case, I wouldn't add any additional secret test case or whatever additional. If you pass all the test case, even I think some student, yeah, their mistake is beyond my touch. Yeah, they still pass all the test case, but they still miss out something. Well, in that case, I still give you the full marks. Yeah, but probably next time I will add more test case to test those special case. Yeah. How will we be test during the lab test? I will give you probably 3 to 4 programming question. You need to solve it in 2 hours. Yeah, that is the lab test. So you expect the lab test question will be easier than the assignment. Assignment, I trying to set it a little bit more tedious. or tricky one, so that you you have 2 weeks. You can discuss with your friends. You can go and try. Yeah, keep trying and trying and trying. You have 336 hours to play on it. So yeah, that is trying to let you practice. The objective is just not just simply find out the answer. It's like when you make a mistake, yeah, how you do the debug is something you need to learn. How to debug your own mistake. Yeah, how you find out your mistake by your own. That is the things you need to learn in the assignment and the lab section. And then the lab test is really test you whether you learn those things or not, Yeah, so assignment is each assignment contribute 5%. 8, 5, 8, 5, 40, yeah. So if you finish all the assignment, you got 40%. Yeah, so each assignment is 5%. Will it be similar to the... Yeah, my answer is no. It will be easier. I would say it will be easier than the assignment. Assignment trying to design in such a way that, yeah, you really can practice. If it's the question can be done very easily in the assignment, then probably you don't really, because you can refer this, refer that, and then trying to figure out what is the problem. You must let you know that I must make it as hard enough in the assignment so that you will make some mistake here and there, and then you will spend time to go and debug. If it's those questions, it's like you can instantly solve it, then you won't realize that actually you don't know how to how to use a debugger. A lot of time I find during the lab test, many students face is like they have no idea how to use a debugger, or they don't want to use a debugger. During the lab section, I already see a lot of students, they don't want to use a debugger. I have no idea why. They want to instantly, one time, definitely I get the answer. I wouldn't make any mistake one. I don't want to make any mistake. But this module, you need to learn how to make the mistake and how to find out your mistake and how you correct the mistake and how you let the IDE, the compiler, to help you, the debugger to help you to fix the mistake you make. Yeah, this and you need to practice during the lab section and the assignment, because during the test you just trying to learn how to use this feature is too late already. Yes, we only able to provide one IDE during the lab test. So take note, we only have the code block during the lab test. Yeah. Yes, that is the learning process. Some students may spend days to solve the problems. You make a small mistake, sometimes you take days to find out where, and when you find out, it's like actually you just make a small typo only. But that is the mistake you need to learn during the term time, not during the test. If during the test you make such a mistake, you need to take days, obviously you won't do well in your lab test. But at that time, it's too late. You just realize that you will make such a mistake during the lab test. It's too late already. But during the term time, you make such a mistake, it's still okay. You have 2 weeks to spend. Yeah, it's okay. Right. So are there test cases provided? Same thing will be provide some sample test case to use. And then again, there are another set is the hidden test case. Will be that particular format will be similar to your assignment. So again, this is something you need to learn. Like when you understand the problem, you need so-called the understand the problem is you need to go and think how many combination are there? What are the special case I need to consider? Normally we do is we was first trying to solve the general scenario. After I able to solve the general scenario, I will start thinking that what else I miss out. Is it there's any special case I need to consider, like even number, odd number, or maybe when you have certain thing at the beginning, or you have certain thing at the back, or you have certain thing in the middle, is some additional case I need to consider. These are the things you need to figure out by your own. Yeah, so there will be the hidden, yes. Why the computer in the lab? Yeah, sometimes it's because those are the lab is they all are using the image, so actually it's from the server. The OS is not really in your computer. So okay, so that is the today lecture. If you have any further question, you can try to drop me an email. But sometimes I may miss because every 1 hour I can receive 5 to 10 email from 800 students. So sometimes if I didn't reply you, it's just I simply missed that particular email. Too many email coming in at the same time. Okay, so you probably need to resend the email again to me. Yeah. Okay, if no other question, that is today's lecture, and see you on Tuesday. Tuesday 12:30. Okay, and goodbye.